This is SpaceTime, Series 23, Episode 17. Coming up on SpaceTime, a new study suggests that Mars could have liquid water on its surface. Astronomers confirmed the discovery of a new exoplanet, and auroral activity discovered around a star for the first time. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that Mars may well have liquid salty water on its surface at least for a few days a year. The findings, reported in the Astrophysics journal, is another piece in the puzzle of water on the red planet. Evidence from both orbital images and ground-based observations have confirmed beyond a shadow of a doubt that Mars was once a warm, wet world, with numerous large lakes and a massive northern hemisphere ocean fed by flowing rivers and streams. Images clearly show dried-up riverbeds and deltas, shorelines, and even beaches. However, as the planet's core cooled and began to solidify, the Martian geodynamos ceased to work, shutting down the planet's protective magnetic field. And this allowed radiation and solar wind activity to erode away most of the planet's once thick atmosphere. As atmospheric pressure fell, it reached the Martian triple point for water. That's the point where water can exist as a solid, liquid and gas at roughly the same time. What it means is that as temperatures rise on the red planet's surface, frozen water ice sublimates directly from a solid into a gas. Observations show there's still significant quantities of water on the red planet today, frozen at the polar ice caps, as permafrost deep below the surface, or as clouds in the atmosphere. There, some of the water molecules are split into separate hydrogen and oxygen molecules by radiation from the sun, allowing the hydrogen to then degas into space. And so, piece by piece, Mars is losing its water. On Mars, water freezes into ice at 0 degrees Celsius and boils at just 10 degrees Celsius because of the relatively low air pressure. However, water containing salts, such as sodium perchlorate, can stay liquid down to minus 70 degrees Celsius, and it won't start boiling and becoming a vapor until temperatures reach as high as 24 degrees Celsius. Under those conditions, there could be liquid water on the planet's surface, as long as it's salty enough. Previous studies have suggested that some patches of frost above perchlorate salts could melt into a briny salt water, which can then remain liquid at lower temperatures and pressures than fresh water, and so could briefly survive on the Martian surface as damp soaks. Some areas of Mars, such as Gull Crater, have the right temperature and humidity conditions at night and just after sunrise during the Martian winter for moisture in the atmosphere to be absorbed by salts on the ground, potentially forming salty liquid water. And of course, chemical analysis of dark streaks, known as recurring slope lineae, which are often seen flowing down the sides of valleys and cliff faces during the Martian summer, have also identified the presence of hydrated salts, again a signature of liquid salty water, in this case possibly from melted subsurface permafrost. In this new study, Norbert Schurghofer from the Planetary Science Institute has developed a hypothesis that briny water could form on the Martian surface for a few days every year in the shadows behind boulders at mid-latitudes. He says the continually shaded area behind the boulder would be extremely cold, which would accumulate water ice in winter. Then, as temperatures increase again in spring, the ice would suddenly heat up. Now, his calculations suggest that the temperature would rise from minus 128 degrees Celsius in the morning to around minus 10 degrees Celsius at noon. Now, that's a huge temperature change over just a quarter of a day. And over such a short time frame, not all of the frost would be lost into the atmosphere. And as we said earlier, salt depresses the melting point of water, so on a salt-rich ground, brines of salty water would form until all of the ice had finally turned into either a liquid or a vapor. And that same process would repeat itself year after year. He's called the process crocus melting. That's because the shadowed areas behind the boulders are so cold in winter that not only water frost, but also carbon dioxide ice would build up. For Mars, the first day without carbon dioxide ice in spring is called the crocus date. And as water melting would occur on or immediately after the crocus date, the term crocus melting seemed appropriate. You're listening to SpaceTime. Still to come, astronomers confirm the discovery of a new exoplanet located just 250 light-years away, the detection of the first stellar aurora, and later in the science report, a new study warns that having 10 or more sexual partners in a lifetime has been linked to an increased risk of cancer. All that and more still to come on SpaceTime. Astronomers have confirmed the discovery of a new exoplanet located just 250 light-years away. The planet, catalogued as TOI 257b, has about 40 times the Earth's mass and about 350 times its volume, suggesting that it's a mostly gaseous world. It orbits a spectral type F white star of about 1.4 times the Sun's mass and almost twice its radius, circling the star every 18 days. Having such a close-in orbit suggests the planet's tidally locked with the same side always facing the host star, and that would give the planet's cloud tops temperatures of around a balmy 1300 degrees Celsius. TOI 257b is an example of what astronomers are calling sub-Saturns. As the name implies, these are worlds larger than Neptune but smaller than Saturn. It's a type of planet not found in our solar system. The data also suggests the system could contain a second planet. If so, it would be catalogued as TOI 257c. Astronomers are hoping to confirm whether or not it really exists in coming months. The study's lead author, Brett Addison from the University of Southern Queensland, says the planet was initially detected by NASA's Transiting Exoplanet Survey satellite TESS, and then confirmed by the Minerva Australis optical telescope array. Minerva Australis is an array of 5 70-centimetre aperture robotic telescopes at the Mount Kent Observatory near Greenmount in Western Queensland. It's the only dedicated exoplanet hunting facility in the Southern Hemisphere, and so far has played a key role in the confirmation discovery of 19 exoplanets. As of January, TESS has found more than 1,604 planetary candidates, with follow-up observations so far confirming 37 exoplanets. Addison says warm sub-Saturns like TOI 257b are among the rarest currently known exoplanets.
So Mount Kent is part of USQ, and Minerva Australis uses high-resolution spectrographs and multiple telescopes to follow up TESS transiting exoplanet candidates with the radial velocity technique.
That's the Doppler method.
Correct.
All right, so TESS finds these things using a different method, the transiting method, that is involving the light from a star dipping just a little bit as a planet transits or passes in front of the star, and then once it's seen that a few times and it thinks there's a possibility that this planet's orbiting that star, then you guys take over and try and confirm that, I take it.
Yep, that's correct, and that's exactly what happened with TOI 257b. So TESS observed 2 transits, and the community was alerted that there were 2 transits around this host star, and we ended up following up this star. We made many observations with the Doppler wobble or radial velocity technique, and from those observations we were able to confirm the planet because we saw the radial velocity orbit, which is basically we measure the velocity shift of the star when the star moves towards us and away from us as the planet is orbiting its host star.
Yeah, so with the planet like, say, the Earth orbiting the Sun, it's not just that the Earth goes around the Sun, but the Sun also moves a little bit from what we call the barycenter. And in the case of the Earth and Sun, it's less than, a few centimetres, I guess. But in the case of this exoplanetary system, TOI 257, the spectroscopy you're using is so precise and so fine, you can see the star moving slightly as the gravitational pull of the planet causes it to move off center.
Yep, that's correct. And our precision is on the order of a few meters per second. So this is just a little bit faster than walking pace, which is pretty cool when you think about it, that you can measure the wobble of a star hundreds of light years away when it's moving only basically at walking pace. So it's pretty incredible when you think about it.
What can you tell us about the characteristics of TOI 257b?
So with the transit method, we got the size of the planet. So the size of the planet is about 7 times the size or radius of the Earth. Put that into perspective, Saturn is about 9 times the size of the Earth. So this is a little bit smaller than Saturn. Neptune and Uranus are about 4 times larger than the Earth. So the size of the planet is between Neptune and Saturn, and it's what we call a sub-Saturn. Now, with the data that we collected with Minerva, we were able to measure the mass of the planet, and that's based on the amplitude or the size of the wobble that we see. And from that, we were able to measure the mass as being around 42 times the mass of the Earth. And to relate that to the solar system, Saturn is about 90 times the mass of the Earth, and Jupiter is over 300 times more massive than the Earth. So it's less massive than Saturn and Jupiter, more massive than Neptune and Uranus, which are about 14 or 15 Earth masses. Now, with the size and the mass, we can use that to determine the overall density of the planet. And from this measurement, we determine that the planet is less dense than water. And it has a similar density to Saturn.
So it would float in the bathtub?
If you had a bathtub large enough, yep.
And by knowing its density, you can start to provide some estimates as to what its composition is likely to be.
Exactly. So based on its density, we know that this is a gaseous world. So it's composed mostly of hydrogen and helium. It probably has a small rocky core, maybe on the order of 5 to 10 Earth masses, and the rest of the mass of the planet is in the form of hydrogen and helium gas.
What do we know about the star that it's orbiting?
So this star is larger and more massive than the Sun. It's also hotter than the Sun. It's about 6,100 Kelvin, whereas our Sun is about 5,700 Kelvin. So it's a bit hotter. We also know that the star is starting to evolve off what is called the main sequence. The main sequence is where a star will live most of its life, where it's fusing hydrogen into helium, which produces energy. That's why stars glow. But there's only sort of a finite amount of hydrogen inside the star's core where the fusion takes place. So in the case of TOI 257, the star is starting to run low in the hydrogen fuel, and it's starting to expand.
So this is a spectral type F star. It's starting to fall off the main sequence. So soon it will go through helium flash, I take it.
Eventually. I'm not sure exactly when that will be, but probably in another maybe a few 100 million years.
Well, that's reasonably soon for astronomical terms.
Astronomical terms, yes, exactly.
And so when that happens, the star will expand, and there's a good possibility, because this thing's only the orbital period's only 18 days, so that means that TOI 257b will probably be gobbled up and disappear.
Yep, it probably will. It will likely be consumed by its host star, maybe in a couple 100 million years from now. But that's a long time on human scales, but in astronomical terms, that is pretty short.
And it's not alone, is it? It looks like there's some tantalizing evidence there may be a second exoplanet in the system, 257c.
Yes, that's correct. So using our data, we have some pretty strong evidence that there's another planet, probably similar mass. We don't know the size because we don't see transit events for this outer planet. But our radial velocity data reveal that there's another planet on about a 71-day orbit. So this looks like it's a multi-planet system, and that's pretty exciting.
When we look for these planets, we're finding a lot of them at distances much closer to their host stars than planets in our own solar system are to the Sun. Is that bias caused simply by our ability to detect them?
I think a lot of it is bias, because it's much easier to detect using the radial velocity method close-in planets, because the wobble of the star is greater if the planet is close to its host star as well as being more massive. So with that technique, there's a bias towards short-period massive planets. Similarly, with the transit method, short-period planets are more likely to transit their host star from our point of view, because the transit probability is higher. And also, larger planets are easier to detect with the transit method as well because you see a larger depth. So with those two techniques are biased towards short period and larger planets.
Why is it important to look for exoplanets? I mean, we have 4,000 of them now that we know about, so the theory about exoplanetary existence is no longer in question. I mean, that changed with Pegasi 51b, I guess. But why do we want to look for them now?
That's a great question. And the reason why we want to look for additional planets is to understand the population of planets. What sort of planets can exist in the universe? Also, it helps our understanding of how our own solar system might have formed and how the planets have migrated and evolved over time. The holy grail of astronomy is finding another Earth-like planet, an Earth 2.0, that could potentially host life. So that's really the driver of finding more planets.
From your point of view, what's been the most surprising finding about our understanding and the development of our understanding of exoplanets over the last 25 years?
I think the biggest surprise is that you can have massive planets orbiting so close to their host star. Before the discovery of the first dozen or so exoplanets,
these hot Jupiters,
we sort of naively assumed that other planetary systems would be similar to the solar system. And of course, we only had a sample size of one back then. So that sort of revolutionized our understanding of the diversity of planetary systems that we didn't even imagine could be possible.
And I guess it's helped to explain the evolution of our own solar system as well. It explains the late heavy bombardment, for example.
Yes, exactly. That planets can migrate from their initial formation location. So we believe that Neptune and Uranus migrated quite substantially in the early days of the solar system. So we believe that they formed closer in, maybe between Saturn and Jupiter, and then migrated out to their current locations, and that sort of disrupted the solar system a bit and caused the late heavy bombardment.
And they may even have swapped positions too.
Correct.
Yep.
Yep.
And there's also speculation there could have been a third Neptune-sized planet out there that may have been completely thrown out of the solar system, or maybe it's the missing Planet X that we keep looking for.
Yes, I've heard a lot of different hypotheses on that, and there's some evidence that there is a roughly Neptune-sized planet, maybe 10 Earth masses or so, in the very outer portion of the solar system that can explain sort of the orbits of some of the outer objects that we see in the solar system.
That's Dr. Brett Addison from the University of Southern Queensland. And this is SpaceTime. I'm Stuart Gary. Astronomers have detected auroral activity not around a planet, but for the first time around a star. In our solar system, aurora only occur around planetary bodies. Of course, the Earth has the northern and southern lights, the aurora borealis and aurora australis, and auroral activity has also been detected around Mars, Jupiter and Saturn. But if a stellar magnetic field was strong enough, then stellar aurorae are also predicted to be possible. And the new detection, reported in the journal Nature Astronomy, represents the first such discovery. The auroral activity was uncovered by its unusual radio emissions, coming from the interaction of a nearby spectral type M red dwarf and an orbiting exoplanet. The star, Gliese 1151, is one of our nearest neighbours, just 26.22 light-years away in the constellation Ursa Major, the Big Bear. Red dwarfs are the most common stars in the Milky Way galaxy, making up more than 3/4 of all the galaxy stars. They're also very low mass and reasonably cool, just a fraction of the size of the Sun, with only about 1/3 of the Sun's surface temperature. Now, all this means that any orbiting planet would need to be circling very close to the star to be in its habitable zone, far closer than the distance between the Sun and the Earth. And as red dwarfs also have far stronger magnetic fields than the Sun, any planet orbiting in the habitable zone of a red dwarf would be exposed to intense magnetic activity, which would heat up and even erode any atmosphere the planet had. As the planet orbits through the star's magnetic field, it acts like a huge generator, producing a massive current that powers the aurora and the radio emissions from the star. These emissions from the star-planet interaction have been predicted for more than 30 years, but this has been the first time astronomers were actually able to pick it up. The Sun's weaker magnetic field and its greater distance from the planets mean similar currents aren't generated in our solar system. However, the interaction of particles erupting into space from Jupiter's volcanic moon Io with the Jovian magnetic field does generate a similar bright radio emission, which can even outshine the Sun at very low frequencies. The observations around Gliese 1151 are simply a scaled-up version of the Jovian Io aurora. The authors, who are from Astron, the Netherlands Institute for Radio Astronomy, used the Dutch-led low-frequency array radio telescope LOFAR for their observations. This method, only possible with a sensitive radio telescope like LOFAR, opens the door to a new way of discovering exoplanets in the habitable zone of a red dwarf star, and at the same time studying the environment they both exist in. The authors speculate that it's highly likely that nearly every red dwarf hosts terrestrial planets. That means there must be lots of other stars showing similar emissions, and the team are now looking for them. In fact, LOFAR's sensitivity could allow them to find hundreds of such systems in our galactic neighbourhood alone. They say LOFAR will be the best game in town for this sort of research, at least until the square kilometre array comes online. Astron's Gina Maffei reports.
The Northern Lights, or Aurora Borealis, are one of the most impressive natural phenomena on this planet. Now, astronomers from Astron, together with teams based at other institutes, have detected radio waves from a star intimately connected to auroras, which means that there must be an exoplanet there. For this, they observed radio waves with the low-frequency array, a giant radio telescope consisting of around 20,000 connected antennas, spread all over Europe. On the 16th of June 2016, the astronomers spotted an intriguing signal coming from GJ 1151, an ordinary red dwarf star 26 light-years from Earth in the Ursa's major constellation. Stars emit all kinds of electromagnetic waves, but these low frequencies have not been closely studied before. After crossing off many possibilities, the researchers found that there was only one explanation. The signal was being produced by an interaction between the red dwarf star and a planet. This discovery is reminiscent of a mystery from our own solar system in the 1960s. Jupiter is emitting radio waves in sync with the orbit of one of its moons, the volcanic Io. But why? It took a decade of observations, as well as visits by the Voyager and Galileo probes, to find out. The constant volcanic eruptions give Io an atmosphere, and radiation knocks atoms into charged electrons and ions. This means that Io's atmosphere is conducting electricity, while it moves through Jupiter's strong magnetic field. An electrical conductor moving through a magnetic field causes a voltage to build up. The voltage pushes electrons to move along the magnetic lines, spiraling around them and emitting radio waves along the way. For the most part of the journey, the radio signal is weak, but close to the star, the magnetic field lines get more crowded, and the spiraling electrons start to feel each other. They interact more and more, emitting strong radio waves in unison to create a radio wave laser beam. As Io circles Jupiter, this beam will hit the Earth from time to time. Mystery solved. The very same thing seems to be happening on a much larger scale, but this time it is the red dwarf that is providing the magnetic field. Electrons streaming between a planet and GJ 1151 would produce radio waves like those that have been measured. Now, this still has to be confirmed. If there is truly a planet, the waves would switch on as the radiation beam crosses the Earth, and off when it passes. The researchers are now checking other nearby stars, and expect to find dozens more with similar radio waves. This method could provide a new way to discover exoplanets, using LOFAR and future radio telescopes such as the Square Kilometre Array. And regarding those auroras, electrons eventually fall down into the star and crash into its outer layers, causing the shimmering curtains of Aurora. Only in this case, they shine over a star instead of a planet, and may even be visible to telescopes on Earth. And if the newly discovered exoplanet has a magnetic field, like the Earth does, the same thing is bound to happen on the other end. This would cause auroras over an exoplanet, including the accompanying radio waves. We may even detect those. The hunt for exo-auroras is now in full force.
That's Gina Maffei from the Netherlands Institute for Radio Astronomy, Astron. And this is SpaceTime. Still to come, Iran's manned space program. And later in the science report, new observations show crude from the Deepwater Horizon oil spill has been found far beyond the slick's known satellite footprint. All that and more still to come on SpaceTime. Straight out of the "you couldn't make this stuff up" category comes news that Iran's Information and Technology Minister, Mohammad Javad Azari-Jahromi, has tweeted a photo of the Islamic Republic's new high-tech spacesuit developed for the nation's manned space program. Trouble is, he actually lifted the image straight out of the Amazon fashion catalogue for kids' Halloween costumes. Apparently, the kid's spacesuit was on special at just over $20, almost half price. Jahromi, who's a former Iranian intelligence operative, even photoshopped a picture of the Iranian flag onto the silver outfit and then removed the original American flag and NASA insignia. Now, he's been forced to apologise for the bad con job, claiming his team, not himself of course, had undeniably made a mistake in choosing the image. The incident was another crash and burn for Tehran, which just days earlier had failed to launch a satellite into orbit to commemorate the 41st anniversary of Iran's Islamic Revolution. Of course, this isn't the first time Tehran's lied to the world about its activities. In 2013, Iran unveiled its new stealth fighter, the F-313. However, it turns out that aircraft was just a wooden mock-up that couldn't actually move under its own power. And a video 4 years later apparently showing the same aircraft taxiing along the runway was also faked. The thing still couldn't fly. Then there's Tehran's denial that its space program is simply a cover to test long-range ballistic missiles, or that it's been engaged in a secret parallel nuclear weapons development program with North Korea. But Iran's propaganda is even worse domestically, with billboards last year during the 40th anniversary celebrations of the Islamic Revolution even claiming that it was Iran which actually built the space shuttle. Arianespace has carried out its second Ariane 5 launch for the year, placing the new GeoComSat 2B environmental observation satellite into orbit. It was one of two satellites aboard the mission for the launch from the European Space Agency's Crude spaceport in French Guiana, the other being the JSat-17 telecommunications satellite.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage moteur Vulcain. Allumage EAP et décollage VA252. Propulsion nominale.
There we go. Gosh,
Tous les paramètres bord sont normaux.
Moving experience to watch this. It's my second live, but my goodness, it is something else, isn't it, Josh? You've been doing this for years.
I've never seen one from the terrace here, or just now at plus 50 seconds, getting the noise of the liftoff with that delay.
There you go. I don't know if you can hear us, but here we go. And yeah, we have. My goodness, this is a very loud noise. So we have our launch that has passed Mach 1, and it is now moving faster than the speed of sound. Josh.
707
Paramètres bord normaux. Trajectoire nominale.
I hope you can hear me. We need a lot of push, and we have a lot of push, and you can hear it. 5 tons of fuel burning every second.
So we'll be getting rid of those boosters right now. Here we go. Waiting for confirmation.
Séparation des étages accélérateurs.
They fall into a protected area about 500 kilometers from shore. French Guiana, in part, selected as a launch base.
I think it's 9 kilometers a second.
Yes, it is. Do you know why?
Tell me why, Josh.
It's because the satellites are going into geostationary orbit, and that is the speed, roughly, at which the Earth turns. And the geostationary orbit means the satellites are hovering over one particular point on the Earth, Korea or Japan in this case, so flying at the same speed. The engine shut down, and there is separation. There you have ignition of the upper stage, the lower stage falling back into the Gulf of Guinea. These three orders, extinction and separation of the lower stage and ignition of the upper stage, coming on time, given by the onboard computer in about 13 seconds.
Séparation du satellite JSat-17.
And there you have confirmation by the TDO, separation coming right on time over the Indian Ocean, revealing our lower passenger GeoComSat. Tonight representing years of work for many of these people.
Séparation du satellite GeoComSat 2B.
The 5,857-kilogram JSat-17 was the first to be released, being deployed 27 minutes after launch. The high-bandwidth satellite will provide telecommunication services for Japan and surrounding regions for the next 15 years. Its deployment was followed 4 minutes later by the release of the Geocomsat 2B environmental satellite for the Korean Aerospace Research Institute. The 3,379-kilogram spacecraft will undertake environmental and oceanographic monitoring. It uses two primary science instruments, the Geostationary Ocean Color Imager 2 and the Geostationary Environment Monitoring Spectrometer. The spacecraft has a design life of at least 10 years. This mission also marked the 108th launch of the Ariane 5. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study by the University of Miami has confirmed that crude from the Deepwater Horizon oil spill has spread far beyond the slick's known satellite footprint. The BP Deepwater Horizon oil rig exploded on April the 20th, 2010, spewing more than 210 million gallons of crude oil into the Gulf of Mexico. Over the next 87 days after the initial blowout, the ever-growing toxic slick polluted an estimated 149,000 square kilometres. In fact, it remains the largest oil spill in American history, dwarfing that of the Exxon Valdez. The new findings, reported in the journal Science Advances, shows that the slick extended far beyond its apparent satellite footprint, reaching the West Florida Shelf, the Texas shoreline, the Florida Keys, and even along the Gulf Stream towards the East Florida Shelf. The results show that toxic and potentially lethal oil spills can kill wildlife and decimate ecosystems far beyond their satellite footprints. There are growing fears today that up to a third of planet Earth's plant and animal species could be gone within the next 50 years. The study by scientists from the University of Arizona looked at recent extinctions caused by climate change to estimate the loss of plant and animal species by 2070. The findings, reported in the journal The Proceedings of the National Academy of Sciences, has provided one of the first detailed estimates of the broad-scale extinction patterns caused by climate change. They've done this by incorporating data from recent climate-related extinctions and from rates of species movements. To estimate the rates of future extinctions by global warming, scientists estimated local extinctions that have already happened based on repeated surveys of plants and animals over time. The authors analysed data from 538 species and 581 sites around the world, focusing on plant and animal species that were surveyed at the same sites over time, at least 10 years apart. They generated climate data from the time of the earliest survey at each site and the more recent surveys. They were shocked to find that 44% of the 538 species had already gone extinct at one or more sites. Scientists have found that switching from a meaty diet to plant-based foods could reduce your risk of heart problems because it stops your intestinal microbiome from producing a substance that increases your risk of heart disease. The findings, reported in the Journal of the American College of Cardiology, looked at blood samples from 760 women over 10 years and found that those with a more plant-based diet had lower levels of a substance called trimethylamine N-oxide, or TMAO, which is produced when gut bacteria digest animal products such as red meat. And they found that the women with lower TMAO levels were also less likely to have heart problems. Now, this study can't prove that eating meat actually causes increased TMAO levels and heart risk, but it adds to several previous studies which have also linked high TMAO levels with increased heart attack and heart disease risk. What's being touted as some of Australia's first plant foods, eaten by early populations 65,000 years ago, have been discovered in the Northern Territory's Arnhem Land. A report in the journal Nature Communications claims preserved pieces of charcoal recovered from debris of an ancient cooking hearth were found to be the remains of an ancient meal. The discovery represents the earliest evidence of Homo sapiens' use of plant foods outside Africa and the Middle East. A new study has found that a history of 10 or more lifetime sexual partners is linked to an increased risk of being diagnosed with cancer. The findings, reported in the British Medical Journal, are based on data from a nationally representative tracking study of 5,700 adults over the age of 50 living in England. When researchers analysed the data, they found a clear association between the number of lifetime sexual partners and the risk of a cancer diagnosis among both sexes. Now, the authors note that since this is an observational study, it can't establish cause. Nevertheless, the findings chime with those of previous studies implicating sexually transmitted infections in the development of several types of cancers and hepatitis. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free twice-weekly podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.